Many of the functions of which we're going to be taking limits have what are called continuous companion functions, and I'm going to demonstrate this by dealing with this particularly complex function here. So f of x is a function that is not defined at x equals 4. And if we wanted to take the limit at x equals 4, we can't merely plug in, because if you try and plug in, what you get is 0 over 0, which means it's indeterminate, which means we have no earthly clue what the value is actually supposed to be. So plugging in doesn't work. We're going to need to do some algebraic reconfiguring in order to actually evaluate this limit. So what we're going to do is we'll take this expression, and notice that before we can do any kind of factoring, we have to deal with that radical. And we're going to deal with that radical by a trick that we mentioned in a couple videos ago. We're going to multiply by the conjugate. And so the conjugate will be the square root, x squared plus 9, plus 5. And of course, when we multiply the numerator by that, we also have to multiply the denominator by that. And so we're multiplying by the conjugate to use the difference of two squares formula. We have an a minus b times an a plus b, and of course this is going to equal an a squared minus b squared. So this is going to equal a squared, so that is just x plus 9 outside of the radical, minus b squared, minus 25. In the denominator, I'm just going to leave these factors separate, so x minus 4 and then radical plus 5. In the numerator, we'll perform the subtraction, so we get x squared minus 16 over this same ugly denominator. We have to keep on writing it, x squared plus 9 plus 5. Then, notice that this numerator, we can factor using the difference of two squares formula. So we can factor this into x minus 4 and x plus 4, and that's particularly fortuitous, because we can cancel this problematic factor of x minus 4. And this leaves us with this expression, x plus 4 over square root of x squared plus 9 plus 5. And this is g of x. Now, g of x is a function that has a domain of all real numbers. It's defined everywhere. So what is g of x relationship to f of x? G of x is the continuous companion function. And what that means is, in f of x domain, everywhere where f of x is defined, then f of x equals g of x. They are identical wherever f has a value. F has one point that is not defined. It is the point f equals 4, f of 4, which of course equals the 0 over 0 thing. But with g of x, we can plug in x equals 4, because g has a domain of all real numbers. And in fact, when we plug in 4, what we get is 8 over 10, or 0.8. So g is the continuous companion function. It is continuous at the place where f has a 0 over 0 value. And so what this means is that the limit as x approaches 4 of f of x, it's going to be the same as the limit as x approaches 4 of the continuous companion function g of x. And of course, for that, we can just plug in 4 and get 0.8. And so that is how we find a limit using the continuous companion function.